Here are some more situations where we're going to factor, but in these cases we're not trying to factor a trinomial, rather we have a two-term expression like a binomial that we're trying to factor. So we do the factoring slightly differently depending on what kind of situation we're running into. If we look at the first one with 25x squared minus 16, this situation is what we refer to as difference of squares. Difference of squares looks like a squared minus b squared, and it factors into a minus b times a plus b. So this is actually difference of squares. We have to figure out what times what is 25x squared. Well, we know 5 times 5 is 25, and x times x is x squared. So this is going to break down into two 5x's multiplied together, and then 4 times 4 is 16. And so when we factor this by difference of squares, we break it down into 5x minus 4 times 5x plus 4. Okay, so that's how a difference of squares will factor. You have to figure out what's being multiplied together times itself, and then put those together into two factors, one with a minus and one with a plus. Let's look at another one. Let's see, we have 64x squared minus 9y squared. So you may want to pause the video on this one. Go ahead and see if you can figure out how this one will factor. What times what is 64? That would be 8 times 8 is 64. And 3 times 3 is 9. So we're going to break this down into 8x and 8x for 64x squared, and 3y times 3y for 9y squared. And that's going to factor into 8x minus 3y times 8x plus 3y. Now if we look at another situation here where we have 12 minus 3t squared. If you look at this one, this isn't a difference of squares like we had in the last few, mainly because these numbers don't look like anything that you could find a number being multiplied by itself to get to those numbers. Indeed, however, this one does have a trick up its sleeve, and that is to find the greatest common factor of the terms. In this case, the greatest common factor is 3. We can factor out a 3 to give us 4 minus t squared after factoring out the 3. Now what you're looking at here in these parentheses is a difference of squares. The 4 is 2 times 2, and the t squared is t times t. So if breaking that down into difference of squares would be a 2 minus t and a 2 plus t, but with the 3 out in front that we factored out from the beginning. Now in this example we have a totally different situation. This isn't going to be anything raised to the second power. Rather, on this one we have things being raised to the third power. This is what we refer to as the sum of cubes. The sum of cubes goes a cubed plus b cubed, and it factors as a plus b times a squared minus ab plus b squared. There's a similar situation called difference of cubes that happens if there's subtraction rather than addition. It goes a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So they're pretty much the same idea, they just look very slightly different, and the signs are a little different for sum and difference. So in this case, let's recognize what's being raised to the third power to get to 64 and 27? Well, 3 cubed is 27, and along with the x are being raised to the third power. And 4 raised to the third power is 64. So we have a 3x to the third power and a 4y to the third power in our sum of cubes. If we compare this to the pattern that we have over here, this 3x takes the place of a, and this 4y takes the place of b. So when we factor it by the pattern, it's going to turn into a plus b, 3x plus 4y, times, we see a squared. Well, 3 squared is 9, and when we have x along with it, that would be x squared, minus ab. So a and b multiplied together, 3 times 4 is 12, and we have xy together. Then lastly, b squared. The 4 squared is 16, and then the y would also be to the second power. Okay, and then all this together is how the sum of cubes is going to factor.